Welcome to this session. In this session, I'm going to walk you through how Apollo Agriculture relies on two apps to transform the lives of farmers in Kenya. Our apps are built in Kotlin, offline fast, and also use like a lot of server-side driven UI. I'm going to share the server-side driven UI approach, some of the challenges that we faced, and also some of the learnings that we learned as we were working through the whole migration process. A little bit about me. I'm Harun Wangereka, software engineer at Apollo Agriculture. We have two offices. One is in Nairobi, Kenya. The other one is here in Amsterdam. I'm also a Google developer expert for Android. Also an Android author at Codeco. Also like a co-organizer for DroidCon Kenya. And lastly, I'm very active in Android 254 and Kotlin Kenya communities back in Kenya. That's my Twitter handle. You can always reach out to me in case of anything. Apollo Agriculture, what do? We provide modern farming to everyone by providing inputs and also products for Africa 1 trillion agriculture market. Who we are a tech-based company based in Nairobi. We help small-scale farmers maximize their profits. What we do, we bundle everything that a farmer needs. That is financing, farm inputs, advice, insurance, and market access where possible. And how do we do it? We use satellite data and machine learning to enable better credit decisions and automated operations to keep low costs and also process very scalable. Let me walk you through the whole Apollo customer journey, from how we onboard a farmer to how they get like a loan for their products and also how they are able to repay their loans. The very first step, the farmer signs up via an agent or by information via roadshows and also referral from other farmers who are in Apollo pipeline as well. They can sign up via SMS or USSD where they are able to dial a code. After they sign up, we have an onboarding process where we try to collect all the KYC data and also GPS outlines for their farm to help us make credit decisions for their details. After we do the onboarding process, we have like an automated credit decisions. We run all this data through the Apollo credit models, which is fully automated. Once we finalize the whole onboarding process, they are able to get a decision in like 3 hours. Typically, this was like the slide is a bit old, but the current process is like in less than 5 minutes, they are able to get a decision whether their loan is approved or not. When they're approved, they go to pick up. So we have a network of agro-dealers where the farmers can be able to pick their inputs. Once they're approved, they just go to their nearest agro-dealers, and then they are able to pick their inputs. We don't stop from there. We also offer digital advice in form of voice trainings. Once you pick up your inputs, for example, it's a maize planting bundle, we are able to follow up with the farmer to constantly advise them on how better to plant their seeds, how to better maximize their inputs as well. After all this is done, we have the repayment part where the farmer is able to sell their harvest and also they are able to repay their loans. The repayment process is determined by the harvest periods. I think we use satellite data to also make sure that we determine the exact harvest period as well to also start the repayment deadlines. Before walking into those sessions, for context, let me share some of the challenges that we face as we develop apps for our target audience. One of the challenges is devices with raw RAM. We have very small devices which have like 1 GB of RAM, and whatever we do in our Android apps, we have to make sure that it's very optimized for the agent to be able to perform their task without any blockers. The other thing, we have small screens. It's hard to show complex data or even graphs when you have like such small screens. And also, the other challenge is that these devices have low quality cameras. And as I mentioned, we rely heavily on data to make decisions, and we collect a lot of images about the farmer and also about their farm. So we have like low quality images, which makes it hard for us to make decisions at times. We also have like low storage. I think some of these devices are less than 16 GB, which is, I think 16 GB is even better off. So you can imagine the scenario that you have like all this phone with these challenges. And lastly, which is also a crucial part, we have little or no internet access. So most of the farmers are based in the remote areas of Kenya, and some of the farmers don't have access to internet, and also even the agents don't have like access to internet like 24/7. So with these challenges, how do we overcome this, or what does this mean for our Android team at Apollo? As I mentioned, we make decisions based on data. We collect a lot of data and use this data to make a lot of informed decisions. We have to make the data collection very easy and very transparent so that to avoid like the agents repeating the data collections and all that. How we do this is by building a simple app used by agents and agro dealers. We build new screens using a config without having to release new versions of the app. And lastly, we have to build an app that works for low-end devices and works offline as well. This is based from the challenges that I shared. So how do we do this? We have to build a simple and easy-to-use app. We maximize or emphasize more on functionality rather than complexity. It has to be offline fast in a way that once they are in the field and they are able to do like the task or whatever that they are assigned, they are able to work offline, and then later on when they have like an active internet connection, they are able to sync and also submit their data. We have to build highly customizable and dynamic code. In this case, we have to be very careful in that we don't break the app with any changes that we release, both on the backend and on the Android. So the app is very customizable and also has like a lot of dynamic code. We don't want to push breaking changes when the agent is in the middle of the field and they cannot be able to like actively update the app. And lastly, which is the point that I'm going to emphasize more on this session, is we have like a server-side driven UI, which we fully rewrote in Compose, and I'm also going to sharing the journey and also the complete approach. So now to the server-side UI. A bit of context, we use JsonSchema for our server-side UI approach. I'm going to explain in a minute how we use the JsonSchema and what JsonSchema means for us. We have tasks which represent work to be done by an agent, and we also have subtasks, which is like a single unit of work. JsonSchema, it's a vocabulary that allows us to annotate and validate JSON documents. And why did we go for JsonSchema? It's an easy data description between Android and backend. We have like the same JSON response to be consumed by different clients. It can be an Android side, it can be a backend, and also can be like a React side. So it's like an easy and standard format. It's very human readable. And last, we have like it enforces the quality of data submitted by the Android client. And lastly, it's very easy to test for us. Let me dive deeper into the tasks and what tasks mean at Apollo. So it represents like an action to be carried out by an agent. So each task has a list of subtasks that the agent has to complete. So once you download the app, we fetch like the list of farmers assigned to a particular agent. The assigning is per ward. We have like an administrative level called ward in Kenya, and you are assigned like a farmer in your ward. Once you have this list of farmers, each farmer has a number of tasks to be completed, depending on which stage of the customer journey we are in. And each task has a list of subtasks, which represent a single unit of work that is going to be done. All this information is saved in Room database for offline fast approach, because once we save it, an agent can be able to go offline and then be able to do the task, and then later on be able to sync. Let us look at sample task response. That is the JSON. So the key thing here, we have like a lot of fields, but the key thing, we have a label. For example, this task is an instant approval check. And as I was mentioning about the automated credit decisions, this is like a task inside that pipeline where it's a very fast task that an agent has to do to onboard a farmer. It has like a list of subtasks, which I'll also going to explain. As you can see, we have a field which is a list of subtasks. For now, it's empty because I think the subtask field is very large and also cannot be able to fit in the slide. I've mentioned subtask a lot. This is an example of a subtask response. Again, we use the subtasks as a feature screens. So each subtask is a full, complete feature screen. In this case, we have a subtask with a type form. and also a label as well called additional questions. It's a form, as you can see the type there. So meaning, once we're trying to build the UI, we'll build like a form for this sort of subtask. Another key thing to look at here, we have the subtask tag called Farmer Documentation version 2. So we have what we call subtask definitions, and we use subtask definitions to sort of define how the UI is going to look like. And we're also going to dive deep in a moment. Apart from that, we have like a different number of types. It can be a form, as you can see on that subtask. It can also be a map. For example, we need to collect like GPS outlines, so the agent has to go to the farmer's field, collect the GPS outlines, and submit. We also do photo and also audio tasks, subtasks. So audio, in this case, applies where you're trying to send some trainings to the farmers. So the agents receive that subtask, and then they are able to play the training to that farmer and able to like educate the farmer as well. We also have like a bunch of fields, but I think I've explained the key ones that are going to build up in this session. A closer look at the subtask definition, which I mentioned earlier on. We have a form. This is mostly we have like a lot of inputs that we require the agents to perform, like a lot of ask the questions and then perform those inputs. So at the very high level, we have this JSON response, which has these fields. We have a version, so this helps us track like the version of the form. Again, as I mentioned, we have to make it very highly customizable and also dynamic. So in case we need to update questions or in case we need to update a certain form, we just increment the version. And previous apps, for example, if you have on your local database that has like a version 1, you can be able to still use the version 1. And we also have like another version 2 which doesn't break anything. We have a type. So this is the type that, this is the field that we use to determine the type of UI to build, or the type of input field to build. We have the required field as well, properties and triggers as well. Let me first go to the required fields. We have some of the fields that we have are mandatory. For example, let's say name and national ID number, which we require like the agent to input before even completing the form. So this required property or field, we define like a key, a list of keys. Each key represents like a field, and if a field is here, it means that the agent has to complete that question for them to be able to submit like a form successfully. Let's look at the properties, which is like the backbone of everything that we do in the UI part. This is like how it looks. Let me explain a few things. We have like at the very high level, we have referral info. So that represents like a section sort of thing. And it has a title. For example, we have a farmer referral training questions. We have a type as well, which is an object. So for most types which are object we either identify them as sections or headers. Inside the referral info, it has like another properties. Inside the properties, we have like a farmer's code. Farmers who knows code, which is like a single field inside this property. It has a type as well. As you can see, it's a Boolean, and we also have a title. So this is the title that we're going to display on the input. We have another field as well called give farmer card. It's a type of string, and also it has its titles as well, and also have like a list of items. So in this case, we are going to show either, we have like a different types. We can show checkboxes, we can show radio buttons or radio groups. So depending on the type, and a combination of the items, we switch the different UIs as appropriately. So each field is a combination of the section part, so referral info, and also farmer knows code. So that is the key of that input, and that's the key that we use to identify each input in the form. Let us look at triggers. We use triggers to react to certain events. So for example, if you have a task that needs to be shown after an action has been completed, we use triggers for that. So for example, we have this trigger with the event on save. This means once you save the form results, this trigger will be activated. Inside each trigger, it has a condition, and the condition has a type and condition. So this condition on the left part or yeah, is it? Yeah, this right part, it has the key for the input as well, and also has the expected answer. So for example, referral.giveFarmerCard, if the answer is no, that's when the trigger is going to be activated. Once the trigger is activated, what actions do? We have the type there, which is task.hide, which means just hide the task. We also have the parameters where we list the labels to observe for. So for example, take picture of the farmer is another subtask. And all this, what in summary this does is, once you answer no in that previous question, this task with this label will be hidden. So we have like a bunch of triggers to react to different events. This is just one of them. That for hiding, we also have for showing. So for example, if we have like an answer, do you have a spouse? And if you answered yes, it's supposed to ask you for spouse details. So that is another place where you use triggers. Now we have seen the form. How do we represent that in a Kotlin class? We have this Apollo schema, which has all the fields from the form. You can see we have a version, title, description, and all those properties as well. We query this from Room database. Each subtask has a schema, which we query with. We have the schema type, which is like the building block, which helps us to identify which type of UI do we display, or which type of field do we display. Now, how do we build the UIs using this schema? Before we go to the UIs, I want to give a bit of context on why we migrated to Jetpack Compose. Previously, we used Anchor. How many of you know Anchor by a show of hands? Okay. Yeah, so it was deprecated, and it was quite hard to maintain a lot of code base with Anchor. So Compose offers like a reactive DSL for Kotlin and works well with our state-based approach for building UI components. So it was like a new thing that it's similar to what we are doing, but now we have Compose, and we have to take advantages of what Compose offers. So maintaining the forms in Anchor was becoming harder as time passed by. Because it's deprecated, so most of the support is not there, and we have to do a lot of custom things. It was hard to also have lifecycle-aware UI components, and state handling was an issue. This is a key thing in Android nowadays, so where we have to be aware of the state we are handling, and also be very cautious, especially for the apps that we are building. For the low-end devices, we have to be very cautious of state. So moving to Jetpack Compose gave us these advantages. So the approach in high level, we have field types, as I was showing on the schema. And we can have different field types. One of them is the question. We have a spinner, and we also have like a checkbox. Each field type maps to a state. So for example, if we have a spinner, it maps to a spinner state. And after we get all these states and field types, we expose them as a list to the layouts. We have different forms or types of layouts. We have a list, we have a section, and we also have a single question. So a list is where you present all the questions in one list. So for example, if you have like 20 questions, display them in one list. A section is, as I was explaining before, we have like sections in the forms. We display per sections. So if a section has 5 questions, we display that section, and so on. In the single question form, we display per question. Each screen has a single question, each screen has a single question. So we variate this depending on the agents and also depending on how well do you understand the app and so on. So we send these configs on the layout from the backend. So at any point, you can be able to configure which form to display for any subtask or for any agent. After we have the layouts, so in the layouts, they have the knowledge of how to build the components or the UI components per the field type. So for example, if you have a checkbox state, we are supposed to represent like a checkbox. So as I was explaining, the state for each field, we have a base state that defines behavior for all the fields. Each field has its own state. So this helps us like decouple a lot of things, and also we have like a separation of concerns because the validations, for example, we do for like an input field, let's say input and spinner behavior is very different. So we have to create a state for each field. Let's look at the base state. And this is how the class looks like. It has a number of parameters. The key, as I was explaining from the form, which identifies the form. We also have a title, which is the title for that field or that question. We have a previous answer. So as the app works offline fast, we have to ensure that whenever you fill the form, so for example, it's 200, not 200, that's quite a larger number. So for example, 20 questions, you've already filled like 10 of them, and you've not completed. We save that locally and also repopulate that back once you go to that subtask. So that is why we use the previous answer. It's a string, but for this, we customize it depending on the state that we have. We have a prefix, description, and all that, but the other key parameters that I want to look at, we have our validators. We pass like a list of validations with each set. So for example, we need to validate a required and also maximum value and minimum value. So we pass like a list of validators to the state, and each state knows how to handle the validations. We also have a transformation where we, in case we need to change a string to, let's say, an integer, we pass like transformation there. We also have an input type where we pass like the keyboard options for that input. So for example, if you are inputting like age, the input type has to be number. And if we inputting like, let's say, the name of the farmer, the input type has to be like the normal keyboard. We also have a block of utility functions for each state, which I'm also going to show you as well. Let's look at text field state, which is a state for an input field. So has all the parameters and also pass all those parameters to the base state since we are extending base state. The other thing is we pass the type as string. So this enables us to reuse the state as well for the different fields, because different fields require different types of inputs and can return like different types of values. So for example, this will return a string. We can have a Boolean, we can have a list of counties or a list of words. Still on the text field state, so these are the utility functions for this. We have an initial. So in case we need to show like an initial value to this field, we use this method to, or this variable to pass that initial value. We also have like a value. So this one is where we update the value as the user is typing. And also if you have a previous answer, we use that previous answer as well. We have a change method, which is used to just update the value in the state. The other thing is we have the validate, which goes through all the list of your validators. For example, here we have the required, maximum, minimum, minimum length, and max length. So maximum is, for example, if we are asking the age of a farmer, we are expecting it to not be, let's say, greater than 120. So we'll pass like a maximum validation there. Minimum, in case we don't need to serve farmers at below the age of, let's say, 18, that's why we pass like such validations there. And then it will return true if all the validations are passed. We also have the required method, which is from the base state. So this simply helps us on the UI to display an asterisk to simply show a visual thing that this field is required. How do we create a view from the state now? We have a question view, which is like a composable function. Takes in a modifier, so this allows us to customize the size, colors, and all that from the parent view. We also have the state now, where we pass the text field state, and we also have the ondone. So nothing fancy here. We're just doing the normal compose stuff. We have like an outline text field, but the key things to watch at on value change, we try to change the state as the user is typing, and also do the validations as well. So this helps us to provide a UI feedback as the user is typing, which was very hard to do in Anchor. Lastly, we have the keyboard options, where we check the state, which are the keyboard options that we have, and then set the keyboard options there. We also have if conditions. So if the state, if you're supposed to show error from the state, we also check that and then display the error for the user. One thing that Compose really enables us to do is test a field state in isolation. As I've shown you how the simple state looks like, we are able to test all these state in isolation. So let us look at an example. So for example, when an agent types a value, the value is changed. So we have the compose test rule, and then we set the content. In this case, we're using the question view to represent the input field, and also passing a sample state. We also get the view with that tag, and also perform a text input. After we perform that text input, we assert whether the text is equals to what we did. So this is a key thing that really helps us to test all the states, and also test all the views, and also in wholesome test all the layouts in isolation. Let us look at another example. So we call rehydration, which is just repopulating the previous answers. That is like a term we coin internally. So we pass again the question text view, pass it a sample state. We perform like a text input as well. And so for example, in this state, it had like a previous answer of 60. We are just asserting like, is the previous answer 60 in this case? And lastly, we try to change the value again and see is the state updated, because it will be like a bad experience when you don't update the state from a previous answer, because we need to, maybe they entered something wrong, and we need to update that answer as well. Another example of testing in isolation is the maximum validation. So for example, the edge case, we get the node we get the view with that tag, and then perform like a text input, and then assert that the state has that value. In this case, is 201. And then we assert if the error method or the error variable in our state has the value. And also, we assert that we have a text that is, this field must be less than 100 that is shown. So that is a case in a point that we are able to test state and also the different behaviors, validations, and a lot of different behaviors that we have on the forms. Now we have the views, we have the states. How do we create the views from that state? As I explained, we have the 3 types of lists, or types of layouts. We have a single list, section, and also single question. Again, this layout have their state as well, which is a form state. Let us look at how a form state is. It's a class. We use in this state approach, we use like a lot of generics to be able to reuse everything and also be able to pass like a lot of different data types for the states. So it has a fields. So when we are creating the state from the V model, we pass in a list of fields, which we get from the form. We also have the validate, which we try to validate the form if all the validations have passed, because apart from validating in a single input, we have to do the validation for all the form to make sure nothing is missed. We also have a clear form, which is a utility method to just help us clear all the fields. We have a get state method. And we pass a parameter, which is a name. So in case we want to get like a specific state for like a field, we pass in the key and then go through the list of fields and then try to get the state of that field. And lastly, we have the get result, which returns like a mutable map of string and any data type. So this helps us to get the result of the form and then submit the form. Let us look at how the UI code of the form looks like. So a lazy column, which is used to represent a list of items. And we have a when block and also passing like a form state.fields, which we saw in the previous slide. So we are checking for the different field types. And then, for example, the question text view, also casting the state to text field set. So this is one of the downside of using like a lot of generics. We have to cast the state because at this point, we don't know the type of the state. We also now create our question view, pass the modifier, and also pass the state. We also do the different field types as well. And also lastly, in case we cannot be able to determine that view, we just do like a timber or a log. Another thing, we are able to test the layouts. This is how like a test for the layout looks like. We give it a schema, as I was explaining. So we have a schema which is called subtask1, which has all the fields that I was showing before. We pass that schema to our view model by calling the setFormSchema method. We pass the schema, also pass the required fields, pass a prefix. So for example, for fields like phone number input, we require to add like a 254 country code or whichever country that you are in. So that's why we use the prefix. Previous answers, so in case we have a result file that has previous answers, we pass that. And then needs reset is, at times we need to reset the whole form. That is like a conditional to help us start. We set the content to like a list Apollo form, which is the list of all the field, the form that has all the list of all the items. Each form requires a view model, a state, and also a method on submit. So once the agent is able to like complete the form and press the done button, we are able to submit the results. And then just doing a number of assertions and checking whether we have a field called about farmer. So this is like a label inside that schema. So this helps us to test the whole form and also see all the views that we have and also validate whether from this schema that we have, are we seeing the correct field as well. So the app now, let us see how it looks like in UI. So we have the demo farmer. We have a list of tasks, so instant approval, product selection, and farmer documentation. So if you go to farmer documentation, for example, we have a list of subtasks. So we have contact information, and then the other subtasks are photo sort of subtasks. As I was explaining, we have like the different types of subtasks. Let us look at the contact information. So this is a section type of a view where we have initial questions, and then you can see the different types of field now. We have an input, we have a spinner, and we also have, inputs. We also have another thing where we do double entry. For example, you have to confirm your phone number. So that is what is shown on the other screenshot. And we also have like the radio buttons. We also have the previous, next, and all that. Going to the single question view, as you can see, we have about farmer. Each screen represents like a single UI or a single field. This is maybe varied depending on the agent. How do we submit all this now? When you fill the form, we validate and also trigger the triggers. If you once you submit the form, the triggers are triggered as well. If the validations are correct, all fields are inputted as correctly, and all validation, let's say maximum, minimum, are correct, we save the result in a key value pair, as we saw in the get result. It returns like a key value pair. We have inside each subtask, as you saw before, we have a destination URL. It points to the URL that we're supposed to submit on the backend, this data. So this helps us to be dynamic, and also we can change the destination of the responses at a fly without having to update the app. We also have, for images, we rely on AWS SDK. We submit the image to AWS and then get the URL, and then save the URL to that subtask, and also submit the response as the URL instead of like uploading the whole image to a server. So this helps us to be very use resources very well, because the phones, as I mentioned, are not like higher performance devices. So what are the benefits that we gain from using Compose? We have a lot of reusable components now, which we can be able to reuse across all the code bases. Testing both state and UI components is very easy for us, as I shown. It's also easy to provide different form of layouts on the fly. We also extracted all the form logic in a separate module, so it's easy for us to contain the form logic in a module and also test everything, and also in case we need to, let's say, open source that whole logic, it's easy for us. And also, ability to use generic to use state implementation and support any data type. So we don't have to create like a different variations. We have like a base state, and also able to reuse that to come up with the states for the different field types. So some of the challenges that we faced, there were quite a number, but I think to highlight the top two, we had like issues in handling the keyboard, especially because we have a form which has a different types of inputs, for example, a spinner, and also we have radio buttons and all that. So it was at times difficult to handle the keyboard, especially when you need to maybe scroll after the user has completed that a specific input. We have a thing we call conditionals. For example, if we have a field called are you married? And you are supposed to answer yes. If you answer yes, we are supposed to also show a different UI for you to input the spouse details. So this was a bit challenging because we have a dynamic nature of views, and it's also hard to at times determine what the answer is at runtime. Because previously in Anchor, we had like a listener to listen to those sort of scenarios, but now in Compose, we can't attach a listener to each and every field. So this is like a work in progress, something we are still continue researching on, and to find like a better option to handle it. Let me highlight other Compose usages that we use internally as well. Apart from the whole Apollo form, we also have what we call choice expression. It's similar to the form because it helps us reuse the views. We have the same logic on the server side and Android. So it has a JSON, called choice expression, which is a set of questions and choices and their type. So the type determines the input to display. It can be a text field, it can be a radio button. So it provides a lot of choices. A user can choose, and depending on what choice they are either presented with a set of more inputs or the final result. This helps us creating UI for things like input selection, which requires a lot of inputs, and quantities change depending on the answers as well. I'm going to show you like a good example of this. So this is a simple choice expression. It has an operation, which is ask. It has a prompt, which in this case, we use it to display the label, and has a type, which is a Boolean. So on the screenshot, you can see we have do you want, and then provide two answers. Is it a yes or a no? So this is a sample choice expression, and it's UI. So how do we use it at Apollo? So we have like a maize planting bundle where we have to, for example, you have to select your fertilizer and also input the acres. And depending on the acres, we recommend like, for these acres, plant this amount of kgs of fertilizer, or use this amount of fertilizer. So you can see there, select the option, and then depending on the option you choose, you can add more views as well, or you can even see the final result, as you can see at the bottom there. So that is the result. So the result, once we get like the result from this choice expression, we submit it to the backend and also get like a price for the selection that we did. So this enables us to be very dynamic, because the thing we realized that once you're doing like a lot of inputs and also selections, there is a lot of things that change depending on the answer that you've selected. So that's why we call it choice expression. Yeah, and thank you. That was my session. I think we still have 8 minutes for questions.
Hello, Harun. I guess like a quick question about how the schema was delivered to the app. Is that something the users has to download ahead of time and prepare before the inspections?
Yeah, so how it's delivered is once you install the app, you fetch the list of your farmers. Each farmer has like a task, and also each task has subtasks. So we save that locally, and every time now you open the app, you are able to see the task and the schema and all that. The good thing, we have like a lot of background workers, I think, to update these schemas as well. So for example, if you have a change, we do like every 10 minutes, do a sync, and then they're able to get like either new versions of the form or either new tasks as well. Also, the submitting is completely offline. So once you complete a task or a subtask, it's saved locally as a result file. It's a string, as we saw, a map of string and also the data type. We save it locally, and whenever you have like internet, we upload all the results to the internet. So in that case, we are able to completely work offline and navigate the challenges that we face.
Thank you.
Thank you for the question.
Hi. You said that you are showing different forms regarding what input the user gave. This is always going forward. Do you also have the requirement to go backwards in the process if the user made a specific input, or is it just sequential?
Yeah, so we have a number of options. One, I think we save the results locally, and you can be able to update in case you will not submitted. And in case, for example, you submitted and something was wrong, for the automated process, the whole credit decisions part, what it does, I think, it resends you like a sample task as well, and shows an error for the one that you filled wrongly. So in that case, they are able to see this, you filled this wrongly, and you need to like fill another version of the subtask.
Thank you.
Hi. I'm curious about the how do you manage the problem or the situation where, because if I understood correctly, this manages like microcredits and prices, and what about the case where a farmer is so far away that let's say they do the process today, but they cannot get internet until tomorrow, let's say. So is there any kind of guarantee, or how do you manage that kind of scenario?
Yeah, so I think over the couple number of years, we try to optimize our processes per the results per the feedback we get from the agents, because previously it was like a common feedback where they for example, walk like, let's say, 5 kilometers away, and then they have to go again. So we optimize everything to make sure that they're capturing their input correctly, give feedback also on the screen. So for example, for photos, we provide instructions. Let's say we are trying to take the picture of the farmer at the field. Before you even take a picture, we provide instructions. Make sure the farmer is at the field, make sure it's like a portrait photo and all that. So it makes it easier for them to understand over time, and also reduce the number of times they have to go back and refill the questions. So I think, as I said, we try to improve the process as every season, because we normally operate on seasons. So for example, we just closed we were just from the long-range seasons in Kenya. So every season we sit down and then see what are the challenges that the agents were facing and try to improve the process based on that. Because I think initially, for example, the automated credit decision used to take time, and that was a feedback people were giving. So we sat down, improved that to under 3 minutes. You can be able to submit all your KYC data, everything, and then able to get a decision where have you been approved for a loan or have you been denied.
Thank you.
A very silly question. Are these information that are put in and sent or whatever, are they informational, or do they have a contractual character? So meaning, if you have a price, is that a price that is legally bounding, or is it an information? And then you have another parallel process that runs.
Yeah, I think mostly they are central. In a way, the prices don't change very much. For example, the basic package, the prices don't change, which is we try to determine beforehand and then try to tell the farmers this is the price of a basic package. It only changes when you change like the size of your field, or if you choose like different packaging options. Yeah, so that is how it changes. So we try to minimize, because if you see like this is the price, and then when you're going to maybe buy it or maybe take your inputs, you realize that it's a whole different price. It causes a lot of chaos. So we try to standardize everything.
Yeah, thanks for the talk and the insights you gave to the of the application. My question would be, did you think about releasing or publishing the part of, or the engine part of transforming the JSON data into forms, into some kind of library or something like this?
Yeah, it's been like a decision. It's something that we are weighing on, because, as I said, we have like the whole form part in separate module. So it's easy for us in case we decide to open source it and also get like contributions, because we have like various issues, which we also try maybe hear inputs from others. So at some point we might open source it. Not today though.
I think that's it.
Yeah, thank you all for attending my session.